Okay, Vectors 5, question number 6. Okay, this question have a few parts. Okay, the first part of the question is that you have equation of a plane given in Cartesian form. You have the equation of the line given in Cartesian form. Your job is to show that the line L lies in the plane P. Subsequently, so if you actually analyze this, what they're asking you is you need to show that a line lies on plane P. This is similar to example number 8 in your lecture notes. The next part of the question, they supply you with another equation of a line, this time line M in vector equation form, and your job now is to find the intersection of the line M with the plane P. Okay, and this is intersection of line and plane, which is similar to example 5 in your lecture notes. The last part of the question needs some visualization. Basically, this is similar to example 12 in your lecture notes. Okay, so let's handle the parts beat by beat. First part, you need to show that the line L lies in the plane P. So the equations are both given in Cartesian form. The first thing you need to do is to change your equation of the plane P into r dot n equals to P form. Similarly, change the equation of the line L into your vector equation form. So your job is to show that line L lies in the plane P. So the first theory that you need to understand is if the line L lies in the plane P, then this point 4 minus 3, 7, which is along the line L, should also be on the plane P. So I need to do a check on this. So what I need to do is I check 4 minus 3, 7. I put into the equation number 1, which is the equation of the plane. So the left hand side, we replace it by 4 minus 3, 7 dot with 3, 2 minus 1. And then you run through the mathematics, the result is minus 1, which is consistent with the right hand side of equation 1. And with that, you conclude that 4 minus 3, 7 is on the line L and also on the plane P. Next thing, look at the diagram here. If this is your line L, this is my plane P. If line L is on the plane P, the direction vector of the line, this is the direction vector of the line, should be perpendicular to the normal vector of the plane. So I need to test whether they are perpendicular. So I run this check. Direction vector of the line, this is the direction vector of the line, dot with the normal vector of the plane. I go through the mathematics, is equals to 0. So when it's equals to 0, you conclude that the line L is perpendicular to the normal of the plane. And if line L is perpendicular to the normal of the plane, line L must be parallel to P. And since 4 minus 3, 7, which is on line L, is also on the plane P. And at the same time, the line is also parallel to the plane P. You conclude very nicely that the line L lies on P. Next part of the question, they supply you with the equation of the line M in vector equation form. Then they ask you, find for me the point of intersection of the line M with your plane P. So equation of the plane P in r dot n form. So if you're trying to find intersection, the magic word is equate. So what to equate? Equate the equation of the line M with the equation of the plane P. So what I need to do is to substitute this r into this r. So this r from the line M, substitute into the whole equation of the plane P. I have this equation for you to solve. So activate your dot product. You should generate one equation with one unknown for you to solve. And from there, t equals minus 2. When t is equals minus 2, put back into this equation. And that will supply you with the coordinates of the point of intersection of your line M and the plane P. Last part of the question, let's break it up into two pieces. First thing first, you're supposed to write down the Cartesian equation of the plane passing through point A and perpendicular to L. So write down r dot n equals to a dot n. Do you have the normal vector of this plane? Because this plane is supposed to be perpendicular to the line L. This direction vector of the line L must be the normal vector of the plane. So your n must be minus 1, 2, 1. Then it passes through point A. So your point A must be negative 2, 4, 3 that you found previously. So fit everything together, do your mathematics, you should end up with the Cartesian equation of the new plane that you want. Okay, so this is the easy part. The last part, which is the one that's a little bit tricky. Find a vector equation for the line through A, and which lies in plane P, and at the same time is perpendicular to line L. This is extremely difficult to visualize. Okay, to help you, okay, I've drawn a diagram for you, but okay, the theory is exactly the same as 5.3.1 and example 12 in your lecture notes. Okay, so visually what I have is I have a new plane. Okay, this new plane is supposed to pass through point A. Okay, I draw it here, and this new plane is supposed to be perpendicular to the line L. Okay, so this is what I have. So what you need to understand now is, since the line lies in the plane P, okay, since this new line that you're searching for, okay, this line of intersection lies in the plane P, this line must be perpendicular to 3, 2, minus 1. And what is 3, 2, minus 1? It is the normal vector of the plane P. So this is plane P, this is the normal vector. Okay, follow my drawing, they are perpendicular. Okay, so line L lies in plane P, line L must be perpendicular to 3, 2, minus 1. Then this line, okay, this red line that I'm interested in, is supposed to be perpendicular to my blue line as well. So this blue line and this red line, they are perpendicular. So the direction vector of the line L must be perpendicular to the direction vector of the line L, which is minus 1, 2, 1. So your line, okay, this red line is perpendicular to two items at the same time. It's perpendicular to the normal vector of plane P. This red line is also perpendicular to my line L. So going back to the fundamentals behind your cross product, cross product produces a vector that is perpendicular to two other vectors. So these two, if I were to cross, okay, do a cross product of these two items, I'll get a direction that is concurrently perpendicular to 3, 2, minus 1, as well as minus 1, 2, 1. And that is actually the direction vector of this red line that I'm interested in. So cross product then will produce 4 minus 2, 8. So line L, which is the intersection, okay, must be parallel to this. So your job asks for a vector equation of a line passing through A, and then with this direction, fit in your two criteria, you have the equation of the line that you're looking for. Okay, to understand this, okay, you need a diagram. With a diagram, fit in all the criteria, go through the process on your own, see whether you can understand this. If you still cannot understand, okay, you need to go through this question with your tutor in class.